Okay, we're in the index looking at section A, which is the biogas system. So this is, over here, right now you're looking at me, and this is the airlock system, okay? So this is part of the system which is purchased, and the airlock system gets its feed from over here, if you want to take a look back here, and this is the feed system, and it brings in the wood chips or the briquettes or the pellets or the biofuel into here on demand, all under VFD control, into the airlock, valves open, and then it goes through the wall into between the buildings, and we'll go see the gasifier system in a minute. But again, zero oxygen getting in, it's under vacuum, and that's how we're able to efficiently use thermal energy and the thermal process to be able to break the carbon chains into a very small amount, bundles of 3 or 4 or 1. And it's that carbon chain, which isn't a tar anymore, which is a vapor gas that can go right into the gensets themselves. So since we get the generators through this wall, we're going to take a look at the generators, and then we're going to go take a look at the gasifier itself. Yeah, we also have the controls and the VFD panels over here. Everything's on VFDs, all the wires connected, everything's there, the whole thing operates. You can see all the wires right down here going into the electrical room from the cogen system. Everything's completely installed, everything operates. So let's just look at those engines. All right, come on in, let's go see the engines. Got it. So we're in the engine room. You can see the transformer. So the electrical's coming in, and then it's being moved over into the electrical room itself. So the gas comes from the gasifier on the other side of this wall, through those valving, through this tubing. It's a special tubing. And then it gets fed into the system. And then these valves take in so much air, and they have so much syngas coming in, and it goes into the engine itself. We just have this covered for dust. It goes into the engine. So what happens is, as the piston's going up and down, there's about 2% diesel fuel in there. So under pressure, it ignites. And then the 98% approximately is the vapor gas, right? The syngas, it's like a natural gas that's in there. And then there's an explosion that happens. So we're replacing the use of diesel fuel with a syngas, which is made from biomass material. So again, this customization comes with the syngas system to fit on any reciprocating engine that's driven by diesel. So that's how that works and how the system is. So we're buying components that we need to buy, and we'll go see the gasifier next. And this piping and the valving comes with the gasification system to connect to the different engines to run the entire facility on green energy. So we'll go from there. All right, so we're still on A, the biogas system. So the biogas system is in this container, and it through the wall receives the briquettes that we looked at a little bit earlier that come in, or the wood chips into the system. It creates the syngas under vacuum. So with oxygen deprived, it gets up to about 1600 degrees Fahrenheit. And then the chains are broken, and then it gets pumped through the hoses that you saw going into the generators. And then the generators, they exhaust their hot air through here. We collect all the thermal energy that comes around the system, and we pipe all that thermal hot air back to here. So this is customization to the system which we purchased. Customization is the piping, interconnecting, all the electrical, everything's connected. And then it goes through the blower, and then this dryer, the hot air blows along it, and then there's different valves in it that pushes the hot air up through the material, because there'd be material coming through the wall that goes along there. And then the hot air is captured, recycled, it goes through a condenser, and then circles back again. So we're always reusing the hot air as much as we can, and all the energy that we can. If we didn't run the system and we were trying to dry this using natural gas, it'd be $30,000, $40,000 a month in natural gas fees. By using the waste heat coming off of the gasification system to be able to power the dryer, that's the kind of savings that we have. Again, great example why the government is giving us the grant for approximately 1.3, 1.4 million for putting the system in because of its efficiencies and its sustainability and the amount of money that we're able to save them the government for not having to provide us with the natural gas or electricity because of the reduction. So again, all VFDs, all the electricals connected, all the piping is connected. The customization is in the interconnection of all of the different systems at the facility, all of the piping, because we don't waste any heat, we don't waste any products, everything is reused. And for us, it's very exciting because we're not landfilling. Maybe 2% of the material that comes in doesn't meet grade. We're not wasting heat. We're not buying electricity from the grid to run the facility. We're not buying natural gas to run the facility. And we're quite proud of all that. So we'll move on to the last spot. There's a couple other spots I could show you, but I got some things to do. So we're going to head over and we're going to get to the greenhouse and go from there.